Hey folks, welcome back to Engineer Comrades, and today we're going to learn about LXC and LXD containers. We'll see how to create and manage LXC or LXD containers. So here is our roadmap. First, we'll see what is LXC and LXD and how it works. After that, we'll discuss about some features of LXD, and after that, we'll start installing LXD. Then we'll create some containers and we'll see how to manage the containers. So by default, containers use a netted address. So we'll create a bridge interface and then we will map our containers on that bridged interface so that it can directly bridge to our physical network card. After that, we'll also see a GUI way to manage containers. So let's start. First, what is LXD? LXD is an open source container management extension for Linux containers. Actually, LXD uses LXC to create containers, and it is nothing but a management tool for containers. LXD provides new features and functionality like clustering to build and manage Linux containers. So it has some new features if you compare it with LXC. And what is LXC? LXC is an operating system level virtualization method for running multiple isolated Linux systems on a control host using a single Linux kernel. And now we'll see how actually they use virtualization method. So actually Linux kernel provides the CZ group functionality to LXC that allows prioritization of resources, like you can assign a particular set of CPU, memory, block IO, or say network. And you can achieve these things without the need for starting any virtual machines. So LXD act as a lightweight VMs, and the namespace functionality provides isolation functionality that allows complete isolation of an application's view of the operating environment, including process trees, networking, user IDs, and mounted file systems. So in that way, LXC achieves virtualization method from Linux kernel. Here I have listed some features of LXD. First feature is you can use device pass-through capabilities. Means you can directly assign a hardware to the LXC containers like a network device or a USB device or anything. It has also network and storage management capabilities such as storage pooling. LXD also supports snapshots of running containers. Means if you have a running container, you can snapshot that container. LXD also support live migration of running containers between hosts. LXD can also integrate with cloud platforms such as OpenStack. It has got some improved control over compute resources. It also provides clustering, so we can make clusters of LXD containers. So now how we gonna proceed with LXD? First, we'll install LXD on our host. After that, we'll initiate LXD. Actually, you have to initiate LXD before creating any containers. After that, we'll create containers and then we'll see how we can bridge our containers to our physical network device. After that, we'll also discuss a GUI tool which can manage containers in graphical way. So in this lab, I am going to use Ubuntu as my host system. You may use any different distro. The commands will be much of the same regardless what distro you are using. Actually, Snapd provides us a latest package. You may also install LXD using apt-get, but here I am going to use a Snapd. First, I'm installing a Snapd. The command is this: sudo apt install snapd. You may install snapd or you can install LXD using apt-get also. After that, we'll install LXD. So command is sudo snap install LXD. So as you can see, the LXD 4.15 has been installed. You can also verify if it is installed or not. Here you can see the LXD group name. After that, we have to add our username or say user to LXD group. So we're gonna use sudo user mode -a j in caps LXD and my username. So I'm going to use $user, or you may also type username. Okay, so let's type username. After adding your user to LXD group, actually you have to log in again. So you have to log out from your system and then log in again. So I'm going to log out from my system. So now I logged back in to my system. So now run our first command, which is used to check a remote list. So command is remote LXC remote list. So here is the output of LXC remote list. This actually lists a set of lists. From that, our LXC command will pull the images. So first one is from linuxcontainers.org. The second one is local if you have imported any kind of uh, image, LXC image. And the third one is Ubuntu, and the fourth one is Ubuntu Daily. So these are the four remote list, you can say, or say a set of URLs from where our LXC will pull images for our containers. These are nothing but the source of images from where you can pull the images. So if we want to search image of say Ubuntu, then we'll type LXC image list and then we'll mark Ubuntu. This command will give the output of all the available Ubuntu containers available from these sources. So here you can see we have multiple Ubuntu images which LXC fetched from the remote list. You can see here Ubuntu 20.04 is listed. You have got Ubuntu 18, 20, 16. So these are the list of Ubuntu images which LXC actually fetched from the remote list, or say the remote URLs which I have already showed you earlier. So from there, actually, uh, from these four, or rather say three URLs, LXC actually fetched these LXC images. So as I earlier said that before creating any LXC container, you have to actually initiate it. So first, let initiate our LXD. So command is LXD init. So it basically set up a profile for our LXC containers. So just execute LXD init, and then it will ask some set of questions. So would you like to use LXD clustering? So here I'm not going to use clusters. So I'm gonna hit enter, and the default is no. So it will not create any cluster. The next question is, do you want to configure a new storage pool? Yes, we do want. And for the name, I'm going with the default. And here the name of the storage backend to use. This option is a bit tricky. Actually, if you do have a dedicated block of storage, say a dedicated hard drive, or say any storage device dedicated to containers only, then you may use these options also, LVM, CPH, or say if you can create a different partition, then you can also use btrfs also. But we don't have any dedicated partition or say set of storage device here, so we're gonna use dir. So it doesn't need any kind of the external hard drive or say a separate partition. So you have to choose dir here if you don't have any external storage. So next question is, would you like to connect to a mass server? So I'm not going to connect to any mass server. The default is no. Hit enter. Would you like to create a new local network bridge? So for right now, yes, we are going to create a network bridge, but this network will have a different set of IP addresses, because this is not a bridged network which is actually bridged to our network interface directly. So our containers will run on different IPs or different set of IP pool. So for now, we're gonna just hit enter, and after creating some LXC containers, we'll create a bridge to give the same IP address as our host. We'll see that. So for now, I'm just going to hit enter. What should the new bridge be called? So I'm going with default, which is LXD 0. And what IPv4 address should be used? I'm going to use default. And for this also, actually for IPv6, I'm going to use none, because in my home infra there is no IPv6 addressing. So none. Would you like to expose our LXD servers over the network? So if you do need a isolated network, LXC containers, you can go with defaults. If you want to your LXC containers available over network, then you should enter yes. So here I am going to uh, choose the option yes, because I don't need any isolated kind of infra here. So for this option, I'm going with the default one only, and hit enter. Trust password for new client, just hit enter. Oh, sorry, trust password for new clients. Actually, you have to enter your password for that. I'm going to create a password. Would you like to stale cache image to be updated automatically? Okay, so we are going to use the default option. Would you like to YAML LXD init present to be printed? Okay, we are going to use default one only. And now our LXD initial configuration has been completed. So it is nothing but it created a profile for our LXC containers having these all settings. So now let's create a container. So for creating container, we have to type the command LXC launch and then name of the image. So here I am going to use Ubuntu say 18.04, and after that you have to name the LXC. So here I am going to name it as Ubuntu only. So what this command is going to do is it will create a Ubuntu named container which will have a image which is Ubuntu 18.04. So just hit enter. Now it's creating a Ubuntu container. So for the first time, it will pull the image from the internet. So now our LXC has been created and is up and running. So we can check by LXC list command. Yeah, so here you can see uh, Ubuntu named container is in running state, and this is the IPv4 address. The type is container. We haven't created any snapshot yet, So now let's log into our container. So for connecting to container, the command is LXC exec and then the instance name. Here the instance name is Ubuntu. So we're gonna type Ubuntu and then we have to specify what shell we're gonna use. So here we're gonna use a bash shell to connect to Ubuntu, and now we are in our container. You can verify that this has got the IP 10.226.59.194. So this is our container, and you may perform apt-get update to update all the repository. You may also upgrade apt-get upgrade. So let's install Apache 2 on this LXC container, and then we'll expose the port 80 from our host and we'll access the port 80 from outside of that container. So let's do it. So just hit apt get install Apache 2. So now as Apache 2 has been installed, so to expose port 80 uh, to external servers, or say from our host, if we want to access port 80 of that container, we have to execute this command, which is nothing but it is going to add a port which is my port 80, and it will listen on the port 80 and will connect to port 80 only. So after entering this command, it will hit enter, and actually I have already executed that command, so the device already exists. So now we are going to check if that Apache 2 server which is running an LXC container, which is reachable from our host or not. So just type 127.0.0.1 and now we reach the Apache 2 home page. So this web page is actually running in LXC container, and we are using, or say accessing, this web page from our host machine. So in that way we can expose any port of the LXC container to the host. So now let's execute some commands to manage our LXC instance. So first command is LXC list, which I have used earlier. So right now we have a single container is running here, and the name is Ubuntu, and that is the IP address. If you want to stop this container, so simply you can use the command LXC stop, and then the name of the instance, which is Ubuntu in our case. So now our Ubuntu container will stop. So if you list the LXC containers, here you can see we do have a container named Ubuntu, but it is in the stopped state. So in that way you can stop your container, which is LXC stop Ubuntu. Now you can also start your container by using just LXC start Ubuntu. So now let's check if the container is started or not. So yes, the container has been started. You can say the state is running. You may also delete your container by using this command LXC, and then you have to type delete Ubuntu, or say any instance name, or say container name, and by entering this command you can delete your container. So here I am not going to delete my container. Actually I have to show you some thing more on this. So we'll let it be running only. And one more command you can use to list your images which you have already installed, or say which you have already pulled from the remote servers. So you can use LXC image and then list those. So we have actually pulled Ubuntu 18.04 LTS image from our remote servers, and that was 192 megabytes in size. You can also transfer files from from your host to containers or your containers to host. So here I am going to show you LXC file pull command, which will actually pull a file from the container to the host. So first, let's create a file in our container. So for that, we have to log in to our containers. So the command is LXC exec and then the name of the instance, which is Ubuntu, and the shell, which is bash. So now we are connected to our container, and let's create a file. So we're gonna use touch and say ABC, and now we have a file is named as ABC, and it is placed under root. So now log out from our container, and we are going to pull that ABC file to our host. So first, yeah, so here you can see we don't have any file. We're gonna pull that ABC file from the container. So the command is LXC file pull and the instance name, which is Ubuntu in our case, and then the path of that file in the container. So the path was slash root slash ABC, and the path of the host, which is slash home and slash prabhat. Yeah, so actually we have given a space here, which is not required. And now file should be copied here. So here you can see it has pulled a file from our container to our local host. In a similar way, you can also pull a folder also. So you have to only mention -r after pull, which is nothing but a recursive command which gonna pull the whole folder from that. So that's it. So now we'll move on to our next topic, which is so as you can see, our LXC container is running, but it is running on a different uh, IP from our host. So if you'll check the host address, so host is running on 192.168.43.56, the host IP addresses, whereas the container IP is 10.226.59.194. So actually it has created a bridge which is by default giving this IP, and if you want to bridge the container to our physical interface, or say on that pool, you have to create a new bridge and you have to assign that bridge to this container. So we will also do that. So for creating a bridge, you may have or you can have multiple ways to set up a bridge connection. I will show you how to create a bridge using nm connection editor. You may use nmcli or say netplan, but here I am going to use nm connection editor too. So just use this command nm connection editor, nm hyphen connection and editor. So this is the easiest way of creating a bridge, and it's kind of a hybrid way, I'll say, because you can use a GUI tool, and to create a bridge you have to click on this plus sign, and now we have to create a bridge. So you have to select bridge from the virtual section. So just create a bridge, and we are going to create a bridge name bridge 0, and you have to also sign that on which port this bridge is going to be created. So here I am going to uh, select Ethernet, and then I'm going to select my device. So my host is having a Ethernet cable connection, so I'm going to use ENS33, which is nothing but my LAN port. So just select it and then click on save. Hit save, and now you can see you do have a new connection named bridge connection 1. So let's try to up that new created port. So I'm going to use the command sudo nmcli, and the connection up, which was bridge connection 1. Okay, so let's see what we have created. It was bridge connection 1. Okay, so B is in caps. That actually we are entering wrong here. So just put B is in caps. So as you can see, we have successfully activated our bridge connection. So after that, actually we have to only restart our system. Now you can see the ENS33, which was earlier our primary interface, and it is up, but that interface has been not assigned any IP address, and we do have the IP address on our bridge 0, which we have created earlier. So now we have created our bridge 0. So now assign this bridge 0 to our Linux container so that our container can be on the same network address pool. So first of all, I'll check if any container is running or not. Yes, Ubuntu is running. So first I'm going to stop that. So LXC stop Ubuntu, and after that we are going to add this each 0 to our bridged network. So just hit enter after that, and now you can say device each 0 has been added to Ubuntu container. So now let's start our Ubuntu container. So LXC start Ubuntu, and now list the containers once again. Here you can see the container is running, but we haven't got any IP address yet. So actually we have to wait for that. It has been bridged to our bridge 0 interface, and should get the IP of the of our local network only. Yeah, so as you can see, we have got an IP address of 192.168.43.57, which is our local network. So in this way, you can also bridge your containers to your physical network or say your local network. So now your host machine and your container is on the same network. So that's it for the LXD containers. And now we are going to discuss about LXD GUI tool, which is LXDUI. So we are going to install the LXD UI, and then we're going to explore some settings which actually we can alter by using a GUI interface. So first we have to clone the LXD UI from GitHub. So LXDUI GitHub. Yeah, so here it is. From this way you can use a GUI interface to interact with your containers. Yeah, so these are the commands. I will put all the commands and all the links in the description box only, so you can check it out from there. So first we have to clone this. Yeah, so it is not installed actually, so we are going to install it first. Yeah, so now git has been installed, so we're gonna execute our cloning command. So we're gonna clone the LXDUI from GitHub. So has been cloned, and now we are going to install LXDUI. So first enter in the directory, and after that we're gonna install by using pip3 install user command. Just paste that one. Python 3 pip is not installed, so we have to install that one also. So let's install it. So now pip3 has been installed. So now we'll start our installation process of LXDUI. So here you can see we have got some warnings, but there is no error, so we are fine. And now we're gonna start our LXDUI by executing this command python3 run.py and then start. As you can see, the LXDUI has been started on this port 15151. So let's visit that website. Yeah, so we have successfully connected to the web interface of the LXDUI. Now the default username password is admin and admin. So username is admin and the password is also admin. So now hit login. I'm gonna save it, and yes, now you have a running graphical container management system, which is LXDUI, and you can see you have one instance of Ubuntu which is running here, and it has got an IP address of 43.57. You can clone the container from here, you can move that, or you can directly uh, go to terminal of that container. So you can check this. Yeah, so it's 43.57. So you can connect the console from the web UI only. You can clone the containers from here, you can jump it in the terminal of that container. You can snapshot the container, and also after selecting that checkbox, you may stop the container. So now you can say this container has been stopped. You can also start it by just clicking on the checkbox and then hit start. So there are various options of the start, stop, restart, delete, freeze, and unfreeze, which you can execute against any containers which are listed here. You can also create new instances, like you can select the image from here also. Yeah, so we do have only one image right now, so I don't think that it provides all the images from the remote list. One second, let's check in the images section if we can pull the images from here also. Let's verify that one. So I think, yeah. So locally we do have one image which have already pulled Ubuntu 18.04, and we do have these, you know, these container images uh, from our remote list. So actually you can create from this list also. So let's create one. So let's create one. So let's create something which I'm gonna use somewhere. So if you can find a search option, yeah, so we have a search option here. So yeah, so I'm going to create a container of CentOS 8, and let's select the proper image for that, and I think this one is AMD 64, yeah, and this one is good for me, I think. Yeah, so I'm going with this one. Yeah, so here now you can see we are downloading that CentOS 8 image from the remote server. It will take some time to to extract the 123 MBs. So let's wait to finish that. Yeah, so we have successfully downloaded the image. So just close it. Now you can see in our local repository we have two images. One we have used earlier, Ubuntu, and now we have CentOS 8 also in our repository. So check this one, and you can launch the container from here only. So just click on launch container, and now you can name it. So I am gonna name it CentOS 8, and the quantity is 1 actually. It is the number of containers you want to create. So for me, I'm going to create only one container for now, and I am just unchecking this box. Auto start means whenever your host will be restarted, the container will start automatically. So I'm gonna uncheck this one. CPU allocation in percentage, so I'm going with default for now, and now I'm going to create that one. So now you can see our CentOS 8 is created and which is currently stopped. So now start, and let's see if the container is running or not. Yeah, so container CentOS 8 has been successfully started. So jump into the terminal of that. Yeah, so our CentOS 81 actually, CentOS 81 is up and running, and you can check the IP address. Yeah, so by default it is using the netted IP, which is 10.226.59.154. You have to again, bridge to bridge zero interface, and you can have this container also on your local network. So for today, I think we have created container using CLI method. Also, we have seen LXDUI, from where you can manage your containers in a graphical way. So that's it for today. And if you liked our video or say our content, so please consider subscribing my channel and also hit the like button. So we'll meet the next time with some interesting video. So for now, thanks for watching and bye.